graders, welcome to the end of our unit. So in Chapter 2, the last two things we're going to be talking about are ratios and proportions and literal equations. So our objectives are to be able to compare ratios and solve proportions, as well as to solve equations for specific variables. This standard here, we're going to try to make sure that we do really well, because chances are we could be seeing that coming up in the future. In example 1, what we're going to do is we're going to determine if two fractions are equivalent. So it says determine whether or not the two ratios are equivalent. Write yes or no and justify your answer. So one way that we can tell if two things are proportional or equivalent is all we got to do is cross multiply. 7 times 56, we get 392. 49 times 8, we get 392, and if they are equal, then that means they are proportional. So we have a proportional relationship between these two fractions because they are equal in value. Whenever we cross multiply two fractions and we get the same answer on the left side and the same answer on the right side, that means they're proportional. Another way you could check to see if they're proportional is we could take the top, divide by bottom, see what decimal we get, take the top, divide by bottom, see what decimal we get, and if we get the same decimal on the left and the same decimal on the right, that's another way to test if two fractions are proportional. But to me, the easier method, and the one that we're probably going to use most likely in this lesson, is the cross multiply method. So we're just going to cross multiply, and if the number on the left is the same as the number on the right, then they're proportional. So our answer is yes. We have two equivalent ratios. Let's keep going. In example 2, we're going to tell if these two decimals are equivalent ratios. So we're going to use the same method. We're going to look at fraction 1, fraction 2, and we're going to cross multiply them. I'm going to use a calculator to help me with my mathematics. So 0.25 times 2. So I'm taking this number times that. I get 0.5. Now I'm going to take 1.25 times 0.6, and I get 0.75. These are not equal, so they're not proportional. Because of the fact that they're not equal, these are not proportional ratios. That's it for this type of example. Let's keep going. In our next example, we're going to be solving a proportion. So we're actually not figuring out if they're proportional. We're going to tell you that they are proportional. So the left fraction is going to equal the right fraction. What we have to do is we have to figure out what number goes up there. Well, since I'm telling you that these two fractions are equal, we can use the method that we just used in the previous two examples. We can actually cross multiply and say that they're equal to each other. So I could take n and times it by 8 and have 8 n's equals 3 times 12 and have 36. Because of the fact that these are proportional, when I cross multiply, they will be equal. So 36 equals 8 n's. Now all I have to do is divide by 8 to solve for n. So I'm going to draw a line through my equal sign. Divide by 8. Divide by 8. And I get n equals 36 divided by 8. 4.5. So I have 4.5 over 12 is going to equal 3/8. So I'm going to check that in my calculator. 4.5 divided by 12. That equals 0.375. 3 divided by 8 equals 0.375. And as you can see, both of my decimals are equivalent, so I did get the right answer whenever I figured out that 4.5 is the variable n. And again, whenever we started with two fractions already being equal, we can cross multiply them, and then all we have to do is divide by the number that's with the variable, and we get our answer. In example 4, we're working with something just a little bit different. Instead of having just a variable by itself, we have a variable with the number. We're still going to follow the same rules. We have a fraction equals another fraction, which if they're equal, that means they're proportional. Since they're proportional, we can cross multiply. So we're really going to take 3 times 12, and we'll get 36 over here. And we're going to take x plus 4, and we're multiplying it by 4. But this entire thing is multiplying by 4. So it really looks like 4 times x plus 4. x plus 4 times 4 is 4 times x plus 4. Now, since we have a number next to parentheses, that number has to either distribute to both of the numbers on the inside, or we can actually get rid of this number on the outside of parentheses. Since it has to multiply to everything, we're actually going to go ahead and divide it. We're going to divide by 4 on one side, divide by 4 on the other. A 4 divided by 4 cancels out. 36 divided by 4 is 9. We have 9 equals x plus 4. Now we can actually figure out what x is by subtracting 4. Subtracting 4, 9 minus 4 is 5, so x equals 5. So in this problem, our variable x is the number 5. And we could check it. 5 plus 4 is 9/12. 3 divided by 4, okay, well 3 divided by 4 is 0.75. And 9 divided by 12, I'm going to use a calculator, just double check that real fast. 9 divided by 12, 0.75. So in this problem, 5 is the number that belongs there. And again, what we did was we cross-multiplied. We had 4 times x plus 4, so we wrote 4 times x plus 4. And since this 4 right here is multiplying by everything first, we're actually going to go ahead and do the opposite of multiplying by 4 and divide by 4 to get our solution a little bit quicker. So this became a two-step problem instead of a one-step problem whenever solving this problem this way. Let's do another one and then move on. Alright, in example 5, we're actually going to be solving another one, kind of like the previous one. We have x minus 6 divided by 16 equals 5/8. So we have two fractions equal to each other. And again, since we have two fractions equal, that means we can cross multiply because they're proportional. So we can take 5 times 16. 5 times 16, that's 80, equals, we can take x minus 6, or we can take 8 times x minus 6, and I'm going to do that way. 8 times x minus 6. And since I know that this number 8 is multiplying to this entire number inside the parentheses, what we're going to do is we're going to divide by 8. And if we divide by 8 on one side, we divide by 8 on the other. 8 divided by 8 cancels out. 80 divided by 8 is 10. So we have 10 equals x minus 6. And now if we want to solve this, all we got to do is add 6, 10 plus 6 is 16, and x equals 16. We can check our answer. 16 minus 6, that's 10. 10 out of 16, and we have 5/8. Alright. Another way that you can check two fractions to see if they're equivalent is see if you can divide the top and bottom by a specific number to get to the other fraction, or even multiply the top and bottom by the same number and see if you can get to the other fraction. In this case, I know that 10 can go to 5 by dividing by 2. So 10 divided by 2 is 5. 16 divided by 2 equals 8. And 5/8 is the same as 5/8. So these two fractions are in fact equivalent. They're exactly the same. So this is my answer to this type of problem. In our final example for lesson 6, we're going to do this problem here. So we are still doing lesson 7 right after we do this problem. We're going to go right into lesson 7. So we're going to finish up lesson 6 with this example. 6 examples for lesson 6, and we're going to look at lesson 7 right after this. So it says, the scale on a map of the United States is 1 3/8 inches, which is equal to 750 miles. The distance on the map between Washington, D.C. and Los Angeles is about 3 7/8 inches. What is the distance between the two locations? So in our problem, we're going to write two fractions, okay? And whatever we put on top, we want to keep on top. And whatever we put on bottom, we want to keep on bottom. So in this case, I'm going to put my inches on top. I have 1 3/8 inches is going to equal 3 7/8 inches. And on the bottom, I'm going to put my miles. Well, I know that 750 miles is equal to 1 3/8 inches. Our job is to figure out what 3 7/8 inches equals. So this is where we're going to put a variable. Well, and now we're looking at a problem that's proportional. Since it's proportional, we could actually cross multiply and then divide, but before we do that, we might want to change our fractions to mixed numbers so that way they're easier to move. So 1 times 8, so we multiply by the bottom. 1 times 8, that's 8. 8 plus 3, that's 11. So we have 11/8 over 750 equals, I'm going to change this, 3 times 8, that's 24. 24 plus 7, that's 31/8. Or 31/8 over x. So now I can actually cross multiply. 11/8 times x is 11/8 x. The other part, I'm going to use a calculator to kind of help me out here. So I'm going to take 750 over 1, and I'm going to multiply the tops. 750 times 31. That's a big number. I'm going to divide that by 8. All right. So if I divide this by 8, all right, another way that you could do this, is you could take 750 times the top, divide by the bottom. And that's what I'm doing. I'm taking 750 times 31, getting 23,250, and then taking 23,250 divided by 8, and I get 2,906.25. Now, we're going to use a rule that we learned in the earlier lessons, like lesson 1, how to get rid of a fraction next to a variable. So we're going to multiply by 8 over 11 on one side, and we're going to multiply by 8 over 11 on the other side. All we got to do is multiply by that same fraction flipped. The 11s cancel out, the 8s cancel out, and we end up with 1x is equal to whatever this answer is. Now, I'm just going to do what I did on this. I'm going to take this number times the top, divide by bottom, and that's about my answer. So, 2,906.25 times 8 divided by 11, and I get 2,113.6. So x is about 2,114 miles. So on a map, this would be about 2,114 miles from the distance from Los Angeles to Washington, D.C. in actuality. So if it measures 3 7/8, that's about the distance between them. Let's go ahead and move on to lesson 7, the last lesson of the chapter. We're going to be doing literal equations. So make sure you pay attention. It's using skills that we've already talked about. We just got to be able to solve for specific variables. All right, so we're moving on to lesson 7. Lesson 7 is all about literal equations. It's your ability to get a specific variable all by itself. And the way you do that is by following my goal. Your goal is to get a specific variable alone. You get rid of anything that's not with the variable that you want alone by either adding it or subtracting it. And after you get rid of anything that's not with the variable that you want alone, then you're going to get rid of whatever is with the variable by multiplying or dividing it. So looking at this problem, I'm going to cover how to do these rules. So first thing we want to do is we want to read our problem. We're going to solve 5 times b plus 12 times c equals 9. And we're going to solve it for the letter b. So in this problem, that is telling us that we want b all by itself. There's 2 variables here. There's this b and a c, but we want the letter b alone. So what we're going to do is we're going to look at b, and we're going to say, what's not with the b? This number. And we're going to get rid of that number by either adding it or subtracting it. So I'm going to draw a line through my equal sign. And if I wanted to get rid of plus 12c, I'm going to subtract 12c. And if I subtract 12c on one side, I have to subtract 12c on the other. 12c's minus 12c's are no c's. We now have 5b's equals 9 minus 12c. Remind yourself, you cannot put these numbers together. In order for them to be able to go together, they have to be like terms. 9 is not like 12c. One has a variable c, one has no variables. So they are not like each other. So you cannot put those together. Now, we look at our variable b. there's nothing else that's not with the variable. So we need to get rid of what is with the variable. So we're going to get rid of this number 5. Well, this 5 is multiplying by b. So we're going to divide by 5, divide by 5. 5 divided by 5 cancels out, and we now have the variable b all by itself. B is going to equal 9 minus 12c divided by 5. And this would be my answer to the problem. Our only goal in literal equations is to get our specific variable alone. And we do that by following these steps here. That's what we did. We have our variable alone, and everything else is on the other side. That's what we're going to be doing in this lesson. Let's start some examples and see what happens. All right, in example 2, we're going to be still using the same rules, same goals for this question here. So we got 2 times a number minus 17 times another number equals 13, and our job is to get the letter y all by itself. So we start by drawing a line through our equal sign. We need to get rid of what's not with y first. So this has 17 with y, so we're actually going to get rid of this 2x. So we look at the 2x and we say, what's the opposite of 2x? Well, the opposite of 2x is a negative 2x. So we're actually going to subtract 2x on both sides. 2x's minus 2x's is no x's. We have a negative 17y equals 13 minus 2x. Now we've almost got the variable all by itself just by moving that 2x to the other side. The only thing we have left to do is we have to get rid of this negative 17 next to the variable y. Well, a number next to a variable is multiplying, so to get rid of that, we're going to go ahead and divide. So we're going to divide by negative 17 on one side, divide by negative 17 on the other. This cancels out, and we get y equals 13 minus 2x over negative 17. Now, sometimes you might see that they're not going to have a negative on the bottom. So what happens is they change all of the other pieces on this side. So you would say, if I have a positive divided by a negative, we would have a negative 13. If I have a negative divided by a negative, I'd have a positive. So another way this could have been written is you could write that y is equal to a negative 13 plus 2x divided by 17. So these are the 2 different ways that it could be written. Most times, if you just do it this way, I'm going to accept it. But sometimes they want the denominator to be positive. So if you want the denominator to be positive and you have a multiple choice answer, this one would be that answer. Remind yourself how we got there. We took a positive, divided by a negative, got a negative. We took a negative, divided by a negative, got a positive. And so all we did was move the negative from down below to up top, and 2 negatives make the positive. So both of these answers are correct. I would suggest that you try to get to at least this one. This one is just a way that if you had multiple choice and you didn't see your answer, you might want to look to see if you divided by a negative to get that option there. Alright, let's keep going. Alright, so we're looking at our 4th example here, I believe. Maybe it's the 3rd. Sure, I think it's the 3rd. I'm just going to leave it as 3rd. Alright, looking at our 3rd example here, we're going to be solving 7x minus 2z equals 4 minus xy, and we're going to solve for the variable x. So in this problem, we actually have 3 different variables. We have x, y, and z. And our goal is to get the variable x all by itself. I put some steps down here that we're going to kind of follow. The first step is we're going to get the variable to one side. So we're going to pick a side. We're going to pick the left side or the right side, and we're just going to move one of these variables to the other side. And to move a number, all we got to do is add it or subtract it. The next thing we're going to do is we're going to get rid of whatever doesn't have the variable. Because looking at this, if there's something that doesn't have the variable that we want alone, like this has negative 2z, we're going to get rid of that by adding it to move it to the other side. Or if we're looking at this side, we could get rid of this 4 by subtracting the 4 to move it to the other side. Again, it matters what side we pick to have our variable on. After we move our variable, you're going to see how this property works. This says distribute. What we're actually going to do is instead of putting a number in, we're going to take a number out. Because distribution is not just multiplying numbers in, but also taking numbers out of both problems. And the last thing we're going to do is we're going to divide by whatever is multiplying by our variables. So we're going to do these 4 steps here to solve this problem. So pay attention to how we do this, because we're going to do one more after this, and then we're almost done with this lesson too. So the first thing I'm going to do is I'm going to draw a line through my equal sign. And I'm going to pick what side I want my variable to be on. Well, I have a bigger variable over here, so I'm going to move the smaller variable to the bigger variable. Since this is a negative, I'm going to put a 1 there just so I know what type of xy I have. I have a negative 1xy. So if I want to move that number, I'm going to do the opposite of minus 1xy. And I'm going to add 1xy. And if I add 1xy to one side, I'm going to add 1xy to the other side. I'm going to go ahead and draw a line. Well, I have 7x, so I'm going to write 7x plus 1xy minus 2z still on this side, and none of these can combine because none of them look the same, equals just 4. Negative 1xy plus a positive 1xy cancels each other out. So right now, the only thing we did was we got the variable to one side. The variable that we want by itself is the variable x, and we just put it on the left side. Now it's only on one side of the equation. The next thing we do is get rid of what doesn't have the variable. So looking at this, one of these pieces doesn't have the variable. This one. We're going to get rid of it by adding it or subtracting it. Since this is a negative 2z, we're going to add 2z. And if we add 2z to one side, we add 2z to the other side. A negative 2z plus 2z cancels out. So here we have 7x plus 1xy equals 4 plus 2z. Really large problem so far. But again, now the only thing we have on the left side is something that has our variable. Our variable is the variable x. Nothing that has the variable x is on the right side. So everything that has the variable x is on the left. Nothing that doesn't have the variable x is on the right. And again, it's because we wanted the variable x all alone that we had to put it on the same side. Now, we're going to do distribution property. This part here. And instead of multiplying a number in, we're actually going to divide a number out. The number we can take out of both of these goes on the outside, and what's left stays on the inside. So looking at this, I have 7 times x plus 1 times x times y. Well, if I have all these multiplying, I can divide x out of both of these. So the x is going to go outside of my parentheses. X divided by x, it went outside, so I just have 7 on the inside. Plus, if I take that x out, I still have 1 y on the inside. So all I did was, I took the x out of the problem by dividing it. I had x and x, x and x, it went on the outside. So we divided x out of the problem, it's outside. We aren't really getting rid of it, we just moved it out of the multiplication process. So if I were to distribute back in, x times 7, that's 7 x's. That's where I was. X times 1y, I'd have 1xy. So I know that this is correct. It's allowed to be on the outside because I could divide it out, or I could multiply back in and get back where I was. Well, now, if our goal is to get the variable x by itself, we need to establish what this parenthesis is doing to the x. And a parenthesis next to a variable means multiplication. So we're actually going to divide by what's multiplying by the variable. And what's multiplying by our variable is the 7 plus 1y. So we're going to divide by that on one side, divide by that on the other side. This cancels out, and we just figured out our x. Our x is equal to 4 plus 2z divided by 7 plus 1y. Now, I'm pretty sure that some of you are probably going to be struggling with this, and that's okay. We're going to practice one more like this, and then we're going to move on. But we're also going to do some problems in the classroom. So if you have questions, ask those questions in the classroom because I will come around and help you. We're really just following these rules here. Hopefully this is kind of making sense. But again, this is just introducing the topic that we're going to be working on in the classroom. I decided after some deliberation with myself, this is your last problem. So what we're going to do is we're going to solve this problem. 12 times A plus 3 times C equals 2 times A times B plus 6. And we're going to solve this equation for the variable A. So that means we're going to get A by itself. Now notice I've erased my steps. I'm actually just going to follow my steps based on my rule. The first thing I want to do is I want to move variables to one side. So I'm going to pick what side I want my letter A to be on because A is the variable I want by itself. So I have A on the left, I have A on the right. I'm going to get rid of the smaller one. So I'm going to subtract 2AB, subtract 2AB. I'm going to put my A's next to each other by rewriting this as 12A minus 2AB plus 3C equals, well, 2AB minus 2AB is no AB. And then we just have 6. So already, looking at this, we've got A on the left side. We're going to get rid of the number that doesn't have the variable. So this number doesn't have the variable. We're going to get rid of it by subtracting it. And we subtract it on the other side. 3 C's minus 3 C's, no C's. So now we have 12A minus 2AB equals 6 minus 3C. We're already almost done. The next thing we do is we distribute. We take out the variable that we want by itself, as long as it's in both pieces. So I have an A here, I have an A there. My A can go on the outside, and what's left stays on the inside. So if I take the A out, I have 12 minus 2 times B equals 6 minus 3C. All I did was pull the A out of both these. I took the A out of this, took the A out of this. It went on the outside. Because it's multiplying to these numbers, I can have it on the outside of those. It's still going to multiply by 12 and still multiply by negative 2B. Well, since I know that this A is multiplying by this parenthesis, and I want A alone, I'm going to get rid of this entire parenthesis. Since the parenthesis multiplying, I'm going to divide by that parenthesis on one side, and I'm going to divide by that parenthesis on the other side. This is going to go ahead and cancel out, and I have the variable A is equal to 6 minus 3C divided by 12 minus 2B. And this is my final answer. We will practice some problems in the classroom on Monday. Just make sure you have all of this. You guys did awesome today. Make sure you like this video. I tried to keep it short for 2 lessons. Subscribe if you haven't subscribed, and smash that notification bell so you know when these videos get posted, so you're ready to do your homework and have it ready the next day. You guys did awesome, and I will see you on Monday.